share. Yeah, that's good. Okay. There we go. And all right. So the good stuff is at the end here. I got some news links. So this one was pretty entertaining. So these guys decided to check, there's the troll factories, which are like the ones that messed with the American election. So they found 2 companies that promised that they will create social media buzz about anything you want. They will get you followers and get blog posts and stuff. And so they made a fake company, and then they paid one company a few $1,000 to promote it and make it popular and it have a lot of good buzz. And then they hired a second term to create negative buzz and tear it down. And so they looked at, to learn what they would do. And here's what they do, $150, this many for LinkedIn accounts, and to contact a media source directly and write news articles. And then here's the other guys, social media coach and Russian to English translation and other things, SEO services to promote social posts you write on the other side. And this is what's happening since the Trump campaign and a couple of campaigns before it, and every campaign now. This is how you succeed in anything. You want people to believe something, you pay people to make fake social media to promote whatever belief you want, and they will write messages to push it one way or another. So it's probably good to have this kind of research to begin understanding how this works. It's sort of a new form of spam or malware, sort of. So anyway, it's good to see that kind of work going on. Begin to understand it. These are the new killer robots, which look actually pretty good. They got dramatic music too, but their killer robots will drive around, apparently autonomously, and they will go under the tank and then blow up. So it's just sort of a IED on wheels, or maybe remote controlled. I guess network connected, so not AI, just remote control. But this seems like a really good idea. You probably could just use a toy truck and put a bomb on it, and it would be. Now we've had laser-guided missiles and human-guided missiles for a while, so I'm not really sure how new this is. We already have things that will like follow you pointing at it, or have you point a laser or something. But anyway, it's another way to do it. I'm just not quite sure how valuable this would be compared to something that flies fast. But it might be a way to do it. So I heard about this on the blogs. What's that? Yeah, it's not autonomous. Yeah. Anyway, so Facebook is trying to figure out what to do about political ads, since they were totally used to rig the election, and they've gone back and forth, but they recently decided that political ads can say anything, even if it's totally a lie, because they don't want to get in the business of censoring political speech. And I understand that. That is consistency with the Constitution. The Constitution gives you free speech, and the whole point of that is free political speech. And if you start censoring political speech, then it's going to be really hard to not push one side or the other. And of course, this is because of Trump. Trump is paying lots of money to buy Facebook ads claiming that Biden was corrupt in Ukraine and blocked $1 billion to hide the investigation on his own son, when none of that is true. It's provably all completely false. And so all the truth-checking people say Facebook shouldn't run this ad, it's totally false. And Facebook said, we finally have a policy, and our policy is we aren't going to censor anything about political speech, even if it's totally obviously a lie. Which, anyway, we'll see if they can get away with that or what they can do. It's I've heard a lot of people argue about this, and the smartest people I've heard have said they really should just have to obey the same rules as newspapers. And unfortunately, it's not as simple as never censor everything or obey simple rules. It's you're actually responsible for some degree of truth in what you do, and you're supposed to do some fact checking, and you can get sued if it's not true. And I'm sorry, that's just a lot of work for you, but that's the way it is. And if you don't like it, quit running political ads. But anyway, right now, nobody knows where they are, because there was a special law, which is, you remember in the long days, Al Gore said he invented the internet. What Al Gore did was push for this law. He passed a special law which specifically exempted the internet websites from having to do fact checking or be responsible for what they post to help the internet grow. So the internet still has a special safe harbor to publish any kind of crap and not be responsible for it. And obviously we're living through the end of that, when they will be held responsible for that, just like books and newspapers and TV shows, where you can sue if they say something horrible and false about you. And so we'll see what happens. But right now they do have special privileges to not filter their content. And I think we're, just as a society, getting pretty fed up with that. Anyway, so this, thought I had another one, see what this one was. Yeah, this was, so the NBA had a basketball player that tweeted like, I support freedom in Hong Kong, so China freeze. Because apparently American basketball is incredibly popular in China. to where the NBA makes a lot of their money in China. I didn't know this, but apparently American basketball is really popular. Yeah.
It makes about 1 billion a year last year.
Yeah, and so
it's not a player, it's the market team manager. He put out the.
And so they're very afraid that China will ban them or boycott them or something. So China demanded that they fire that basketball player for daring to say a good thing about Hong Kong. And the NBA didn't do that, but they did like say, we don't support any like controversial political statements and it doesn't reflect the position of the NBA. But they didn't fire the basketball player for daring to say something that might offend China, although that is what China wanted them to do, and they're still arguing about it. And Apple took down this app. I mentioned this before. There's an app which the protesters in Hong Kong were using to find the cops, so they can dodge the cops, and Apple took it down in order to appease China. So, you know, it's this has been the issue for more than a decade of tech companies moving into China and then having to obey Chinese laws, which are very offensive to American principles. So DOE is coming, DOE and DOT, DNS over HTTPS and DNS over TLS. And this test showed that, in fact, pages load faster that way than they do with the old port 53 DNS. The port 53 DNS is, of course, intrinsically faster from a mathematical point of view, but the implementations of it are older and the timeouts are set differently. So in practice, the end result is pages load more slowly over the old unencrypted protocol, if people are worried about that. And I think this is the last one I'll mention. The Chinese program is amazing, where they have facial recognition everywhere, high resolution cameras, and a social profile, keeping track of how good a citizen you are. And this is really rolling out everywhere. And they're increasing. Now they're going to ban all VPNs. Next year when we go to China, we may totally not be able to reach American websites at all that they block, like Google. Up till now, we've been using VPNs, and all the hackers in China we talked to are using VPNs. But they say they're going to ban it all. They're going to totally filter everything. Apparently, they're going to crack down a lot more of the internet. Yeah.
They just announced China has a new camera, 500 megapixel.
Yes, 500 megapixels, so they can take a picture of a crowd and recognize every face to assign points to you for your political capital based on whatever they think, like you're attending a rally, so you're a bad guy. You're attending a patriotic event, so you're a good guy. You're not cheering enough, so you're a bad guy.
There's no way to hide anymore.
Yep, that's you know, it's a technological implementation of the social sanctions where you're like considered a bad person for, you know, holding a politically incorrect view, which is what happened under Mao. You'd have to do a self-criticism and everything if you dared to have any unapproved opinions. Anyway, so let's go on with the 152 stuff. We're here. So today we're talking about the old-fashioned forensics. This is the stuff that started it all, where you would just duplicate the data on a hard drive. And that is, of course, what you do when you have to. So you can do a simple duplication. Now, you could just back up stuff where you just copy the files in a folder, and that's one kind of copy, and that does preserve some of the evidence. Now, you might like to get more than that, but in fact, that does something. And I've heard of cops who take a phone found at a crime scene, and they just page through the messages and take pictures of it. And that also preserves the evidence. Remember, the evidence is the people. You do not have to have a perfect evidence collection to go to court. You just have to do something and then have a human that will testify explaining what they did and saying this is the evidence. It doesn't have to be perfect. However, of course, you would like to use a nice, precise, perfect technique that gets all the data off the phone if you can. That would be the gold standard of data. So here's the plan. You'd really like to get every bit of on the source, including deleted files if you can, and that's nice. So here's the requirements for a high-quality forensic tool. It should be able to copy everything, and it should be able to make a forensic duplicate of it, and it should be able to handle read errors, because hard drives and other devices do have some degree of read errors, and if that happens, you would want it to do something intelligent, like only try a certain number of times, then make some kind of mark, and keep going, and not stop where it hits a read error or something foolish like that. So you would also like it to not corrupt the data while it's imaging it. You'd like it to just read the data and never write. And you want to make some kind of final result that can have a hash value attached to it, so you can make duplicates, so you can repeat it and verify that it's correct. And it should keep logs that log everything that happens, so you have a complete record of exactly what happened, because of course there might be errors, the device might break halfway through the imaging, something weird might happen, and then you'll wish you had a log of exactly what happened so that people can make a decision about what you got and what it means. So you might try to get every bit. Now, this is actually a lot harder than you would think. And ever since hard drives, this has been true of SSDs from the start, that if you get like 500 gigabyte SSD, they actually give you more than 500 gigabytes. And it is mapped. There are extra sectors. And when sectors have a read error, they map in a clean sector on top of it, and the computer does not know that this has happened. So when the computer thinks it's reading sector 10,000, it is not really reading sector 10,000. It's reading some other sector chosen by the firmware of the SSD that does not tell the computer that. So if you want to read every sector on the SSD, you can't. You can only read every sector that is currently mapped to the computer, and you do not know which sectors you're reading. And there are other sectors you are not reading. The same thing is true when you erase them. So there is old data left in sectors where you wrote data, and then it had a read error and decided that sector was bad, so it copied the data to another sector and quit using this one, and you can't reach it to erase it. And you can't read it either. And so that's one issue. And this is not true of hard drives too. Hard drives, after they went above 500 gigabytes, have exactly the same issue. They take sectors that fail and silently replace them with other sectors that are extra. So again, there are sectors that are beyond the reach of your software that contain God knows what, and there's no way to read or write to them. Unless you hack the firmware and replace it with hacked firmware that lets you actually physically reach the sectors the way old-fashioned drives did. And another issue is, of course, there's a part of the hard drive, I don't know about SSDs, but I'm thinking it's probably true for them. They have to have some place to store their own software because there's a processor and a computer program running in the storage device itself. And so it has part of the storage medium is reserved for internal use by the hard disk, and you can't see it from the computer. That's called the host protected area. And you can hack the firmware and then write files in the host protected area. So there've been some people, there was one tool called ProDiscover. I think it's gone now, but ProDiscover's claim to fame was that it would read the host protected area. And technically it would find more data on a hard drive than tools like Encase and FTK. In practice, there weren't any major cases where this mattered. In principle, crooks could hide secrets in the host protected area, but in practice, nobody ever seemed to, so this feature turned out to be a bust. But that's what they did. So once you take a forensic image, you can take a complete disk, which is the physical disk from the start of the usable area of the disk right to the end, every bit stored on it, which if you have an old hard drive, like smaller than 500 gigs, it could actually be every physical sector on the disk because there wasn't this second layer of mapping at that time. Or you could just take a partition, which is a part of the disk that has been assigned a drive letter, which is not the whole disk. Or you can do logical sampling, where it's something like a folder, where the area is assigned to one user. Yeah?
That ProDiscover, did they really enable people to see the host protected area?
They said they did. I never tested it. It had this feature. And of course, it means they have to use some advanced special actions with the disk. I went to a training by the guy that wrote it, and it was pretty cool, but there was never anything in there that was interesting. But I mean, in principle, it did something cool. There's a similar thing. When you reconstruct deleted files, the way most tools do it is they just find something that looks like the header of a JPEG, and then they find something that looks like the end of a JPEG, and they just call that the JPEG, everything from here to there. Now, in principle, it could be fragmented. You could have sectors of it, and then junk, and then sectors of it somewhere else. So most forensic tools don't bother with that. They just take a chunk from a header to the footer and just call it the image, because most of the time, that's the image. But if you look at images recovered from deleted files, in a forensic tool like Encase or FTK, there are some pictures that are sort of broken. You see the first half of the picture, and then some garbage, and then the last bit down here. And there was a tool you could pay like $400 for that would actually reconstruct the images more perfectly by following the sectors and figuring out if they really belong in the image and piecing it together. And therefore, the images would be less broken, and you'd get like 5% more images. But nobody wanted to pay for it much because in practice, you don't really need to get all the evidence off the drive. Like if you want the images, you're probably worried about child porn, and no pedophile has one child porn picture. They've got thousands of them. So if you get 90% of them, that's all you need to win in court. And the fact that there's a few more you could have got is not really worth paying $500 for. And that's, of course, the problem with it, especially in instant response and also forensics, where you're confronted with far too much data. And you're just overwhelmed. You could spend months trawling through all the files on a hard disk, and you totally want to avoid that. You want to find some way to quickly zero in on the interesting stuff and ignore all the boring stuff. Anyway, so you can here's the way disk looks like. You have a boot sector at the start of a disk, so it can boot, which is all the way from floppies and MS-DOS, a really old system, unless you have the modern UEFI. And then you have a partition from the equipment manufacturer that may have more information here. And then you have a partition, especially which might be like drive C, and then another partition that might be drive D. So the physical drive has all that junk, and the logical drive, the partition is inside there. So we can see this live. Let me bring up my Windows cloud machine here. All right. Here's my Windows cloud machine. And we've used this tool HXD. HXD is probably just a friendly hex editor. This is the way it all started. There used to be something called Norton Disk Doctor, which is what you would use for everything. You could do all forensics with just HXD. This is this is where it all started. You just have a raw hex editor. So I'll just go through this again so you can see it.
HXD?
HXD, but there's many tools like this. HexEdit in Linux is just, this is a very simple tool. It is just a raw hex viewer. You can view memory or the disk in just raw hex. You're seeing physically what's on the disk. And this has been around forever, from the days of MS-DOS and everything. This is how you would fix errors in images and stuff if you want to. It's not terribly popular because it's pretty baffling. But anyway, this thing can actually open the disk. So I can open the logical disk here. This is the drive C. And if you do that, then you get drive C, and drive C starts with NTFS to indicate the format, and then down here it has other information, and later on it will have the files that are stored on drive C, like C Windows and all that jazz.
So this is your Mac, though, right?
This is a virtual Windows machine in the cloud. It's Google Windows, Google Cloud Windows.
Cloud.
Yeah, it's a Google. Yeah, it's a Google Cloud Windows machine. Yeah.
But it could be a Mac. On
Yes,
the cloud.
you could do it on a Mac. And if you do this on a Mac, Macs have like 15 partitions. They're mind-bogglingly complicated. I went through it with Kirk one time, and it was sort of mind-blowing. PCs can be pretty simple. Like, it only has one partition, C. Now, if you want to see the physical disk, you can see that too. So I can open disk. The physical disk is here, the raw hard disk. And this is the beginning of the physical disk. You can see it doesn't have NTFS here. This is the partition table, which specifies the partitions on the disk. And I only have one partition, so I haven't used much of it. And if I want to see NTFS, I have to get down to like 10,000 here. So let's see if I can get, let's talk about how to make it there, 3, 4, 5, 6, 7. I could use search, but this will work. C, D, E, F, should be pretty soon.
So the physical disk is on the cloud. Within that is the virtual disk that the
Yes.
PC runs on. And outside of physical, are you at the limits? Is that the real physical disk in some rack somewhere in some cloud?
It is actually a file, like a virtual machine, stored on another disk in its file system, which simulates a hard disk.
Okay, so this is still a thing within a thing within a thing, but you don't
Yes.
see the complete thing because,
Yes.
because there's people there to make sure you don't.
Yes, that's exactly, I mean, I've got a virtual machine which looks like real physical hardware, and what I'm seeing is simulated hardware that is in fact running on real hardware. But they're probably running like 50 virtual machines on a big server, and the disk is probably a storage area network, a disk cluster of many disks. So the actual physical place the data is stored does not match this at all.
And it could be Linux or Unix or.
It could totally be. Yes, yeah.
Can people really understand decoding text?
Understand what?
Decoding text for them.
Oh, sure. Yeah, you can look up, you look everything up. You can find out what's going on here. The NTFS is the mark for an NTFS partition. That's the format Windows uses. And see, here we are at 100,000. So the first 100,000 bytes are used for the partition table and the other information that is, and then when you define a drive C, it starts later. There's earlier parts of the disk used for control structures. So this is the physical disk, everything that's on it. And this is the logical disk, the partition C. So these are two different ways to look at it. You might want everything on C. That's usually what you want if you're running Windows. Everything on C is all you care about. Those are all the files and the operating system is using and all the files you're using. But there is other parts of the disk used for the management of this. And that's the partition table. And then there's a part, I can't see it either of these, called the host protected area, which is used only internally by the disk. And then there's some even more hidden stuff, because some of these sectors are not where I think they are. They're actually, they're replacement sectors because the sector went bad. And there are abandoned sectors that are marked bad that still contain data that I can't see at all. So it is, and as he points out, this is all completely a lie because I'm not connected to a physical hard drive at all. I'm connected to something in the cloud which simulates it. which is probably on a, and that's on some kind of hardware, but I don't have any visibility to what kind of real hardware it's on. It's on some kind of giant storage area network or something, and I have no way to see how many disks there are there or anything.
Some kind of giant server, right?
Yeah, and it simulates. If I looked on my Mac at the local hard disk laptop, I would see something simple like this, or on one of these PCs, it would be true. This is a simulation of that, which is a sort of strange thing to do, but that's where we're at. Anyway, so a complete disk image would be everything, including the partition table and all the partitions, or you could image just one partition, and those would be all the things under one drive letter. So that's this stuff in HXD showing the two versions. You can use FTK Imager. It's a free imager. FTK is a forensic product. It's the one favored by the FBI. It's a rival to Encase. There's basically two leaders. They both run on Windows. They're both very luxurious. They're both very expensive. FTK is one, Forensic Toolkit, and the other one is Encase. And police departments mostly use Encase, and the FBI uses FTK, and corporations use either one. And so the analysis tool that will actually help you hunt through all the files and find all the emails and everything, they charge money for that. But the imager, they make free, because you might need to collect data from a crime scene or something, and they want to make it easy for you to collect the data. So for the benefit of the world, they give you a free imager that you can use to collect data, and then you have to pay to analyze it. So anyway, you can collect a physical drive, a logical drive, or the contents of a folder, or a CD. There's different options here.
So could you collect the whole hard drive and then reconstruct the hard drive and boot it up?
Yes, absolutely. You could put it in a virtual machine and run it, absolutely. But of course, now to do that, you have to have like a USB hard drive that's bigger. You have to have somewhere to put it. But you can make an exact copy of a whole hard drive, and that's what you should do when you're trying to preserve all the evidence.
Around it, fool around with these rescue, save, backup programs.
Yeah, see, backups don't get everything. They only get what's called the active data. They get the files that are still in use. They don't get the deleted files because you don't care about those. But forensic examiners want the deleted files. We want every bit on the disk, even though most of it is not currently in use because there's leftover data in there. And that's likely to be good stuff because the PERT probably tried to delete the stuff they didn't want us to see. So deleted files are quite useful. So you can choose to store it in a variety of images. RAW is DD. So if I image a 500 gig hard drive, I'm going to have a file that is 500 gigabytes in size. That is just a one-for-one copy of every bit on the disk. And these other formats just have compression, which would be a pretty good idea to zip it in various ways to try to make it smaller and easier to copy and move around. So if a suspect tries to delete files or reinstall the OS or reformat the hard drive, they're totally wasting their time. None of these erase any data at all. The only time data is actually erased on a magnetic hard drive is when you write new data on top. And you have to do that with either command line, disk part, select disk, clean all, or with a tool like Eraser that you get, or Derek's Boot and Nuke. There are tools that will actually write on every sector. But if you just throw it in the trash can and empty the trash can or delete it at the command prompt, that doesn't erase anything. It just removes the directory entry to the file saying this sector is now available for future use, but nothing's actually erased until you write new data on top. This is what most people don't understand, so they delete stuff they think is gone, but it's still there. So that's the thing. If you get a whole drive image, you can get things that have been deleted, get them back on a magnetic hard drive, not so much on an SSD. So there's the host protected area and device configuration overlay are these areas that are hidden from the computer's operating system. In principle, nothing of interest should be there. It should just be the firmware used by the drive to run, but you could modify it in principle and put something else there if you really wanted to. All right.
You mentioned that there's an erase software, right?
Yeah, there's erasing software. There's one called steganography. There's one called Eraser. There's a bunch of things. You can get tools that will erase the hard drive.
How long does it usually take for that software to erase?
It takes a long time. It takes hours to erase a whole hard drive. That's why the hard drives don't do it. It wastes a lot of time. So most people don't care. That's why they don't erase anything. They just write on top because that makes faster performance. And so active data is the normal data you can see. The files and folders you created that you could open, those are data that's in use. It has a file name, it has an owner, it has a creation date, it's kept track of. Then there's unallocated space, that space that is not currently in any active file, available space on the disk. If it's a brand new disk, that space is all zeros. If it's a computer that's been used for a while, that has stuff left over from previous files you deleted. And then there's file slack. At the end of clusters, there's a few bytes left over. You can only read and write 512 bytes at a time. That is the sector size. So if I save a file that's like 600 bytes, it'll write 512 in the first sector and then like 88 bytes in the next sector, and then there'll be extra bytes that it didn't use in that sector. So there might be some bytes toward the end of a sector that were from the previous file that was really longer, like 1,000 bytes. So you'll find fragments of data at the end of files. Now, this is really not considered very important because you can't even have a whole image there or a whole file. You've always lost the header, so you're not going to be able to reconstruct a Word document. But in principle, there could be something there important like a password or something. If you wrote a Word document that had your password in it and saved it, and the password happened to hit the end of a sector, and then you deleted it and overwrote it with like an image that only used part of the sector, in principle, it could still be there. In practice, you very rarely find anything good there, but there could be something there. Let's file slack. So you can do a partition image, that's an option. You might do this if you have multiple partitions like C, D, and E, and you only want one partition. That would be a little screwy, but you could do it if you want to. It's not a very common activity. Usually you either go for the active data or you go for the whole drive. This sort of halfway in between thing would only be for special cases. Of course, if you did do a whole partition like the whole C drive, then you'd be able to recover all the deleted files on the C drive. So that's some value, but you won't get the unpartitioned space. A logical image is what a normal backup is. This is where you copy the live deactive data in a folder, like all the things in your user profile. C, users, your name. That would be everything in your documents, pictures, desktop. That's normally what you back up to get your user file. Or you have a system image. It captures everything like C Windows and C Windows System and such. That's a logical image. So you do a logical image if you're only allowed to collect some data. For example, if you have a file server that is shared by many people, like Dropbox. If you go to Dropbox, they could give you an absolute copy of the hard drive, but then you'd have all kinds of people's data, and there's no way that your search warrant justifies grabbing everybody's data, unless you're the NSA. So all you can get is the data that belongs to one user, and that has to be active data, because when a file is deleted, you use information about who the user is. So the only thing you're going to get is the currently indexed files for that one user, and that's what you typically get here. And of course, there are other situations like if you have a storage array, it's outrageously expensive to bring the whole thing down and bring the business to a halt, and it's way too big. So imaging the whole thing is sort of nuts. So normally you would not do that. You just do a live image or a logical image of just part of it. So you can save a logical image, then you should save, you want to get creation times and permissions, not just the contents of files, and you want to have hashes so that you have a integrity hash, so you can tell if you make further copies of this that it's accurate. And you can do these with FTK Imager and Encase. And there's non-standard data. You might have, there's all kinds of other data that might happen. You might have a USB stick full of stuff that somebody saved that's relevant. Everything you get is evidence, right? Somebody hands you something and says, this is evidence. It doesn't all have to be perfectly collected under sterile conditions. Just like, you know, if you find a dead body and there's blood spattered around, that's evidence, even though it was not collected in a standard procedure. You just record where it came from, and then you evaluate what it means later. You say, I don't know who collected this, they found it, I don't really know if it's accurate. That's an issue, but there might be something there that matters. All right, and so when you get anything, you just document it and preserve it, and then it will be argued over later in court as people argue whether this means something or whether it can be trusted. All right, so you have hashes. When you do take an image of a hard drive or a file or RAM or something, you then store a hash value like an MD5 hash or a SHA-1 hash, and that means now if I make copies of it or move it to another system, I can check the hash to make sure the copy is 100% correct. Yeah.
BitLocker, if this enable BitLocker on the PC, would that be standard or non-standard?
If BitLocker is enabled, if this gets encrypted in general, you have a big problem. If you don't have the password or the key, then you can't get anything, really. All you're going to get is encrypted junk. You could copy it, but you can't read it without the key. So this is essentially pointless, and there's no backdoor into those tools either. That's the whole point of them. So basically then, you could try to go to court and demand that the user give you the password, or if you're the NSA, they actually archive all this stuff and try to get the key later. Because, of course, if you wait like 10 years, cracking tools might get faster and you might be able to get in. But, you know, for practical work, you can't do it. And this is the big issue of going dark that the FBI is always talking about. They say people are using encrypted chat and encrypted hard drives, and the world is going dark. We're losing data. And in fact, at least as of maybe 3 or 4 years ago, on the last talk to law enforcement agents, they said, I've never seen an encrypted hard drive. They're not common enough. Nobody's actually using them. I've never had this problem. But I think it might be coming now, because I know Macs really encourage you to encrypt the hard drive by default. And I think PCDs too. I know iPhones are encrypted. So I think it is coming where everything will be encrypted and you can't easily copy it anymore. And then you'll just lose some data. I know now the civil liberties groups say that this is all garbage. We are not going dark. The cops are losing access to some data, but they're also gaining so much more data with license plate readers and cameras and microphones everywhere. The fact is they have more data than they ever had. And the fact that there's some part of our stuff that is actually being encrypted doesn't mean they need to get in there too. Everybody is more and more digital and more recorded everywhere. So you can argue both sides of it. And I know the real evidence to decide who's right would be, have they actually had some cases where the ability to get into the encrypted files made a difference? And they really don't have very many convincing cases there where they can prove that a bad guy got away because we couldn't get in the encrypted phone, or we got in the encrypted phone and that's why we caught this guy. There haven't been a lot of spectacular cases to convince people to take one side or the other in this issue. But it is a very active argument, and it has been for 20 or 30 years. The FBI has always said, don't encrypt everything. And it's happening again with DNS over HTTPS. Now that you're going to encrypt DNS, everybody's freaking out, like Australia and Britain, and saying, you can't do that here, and it's going to ruin everything. We can't block the porn and the malware if you encrypt the DNS. And this is the issue. If you don't encrypt anything, then it's easy for the bad guys to spy on you, easy for your company administrator and the government to spy on you. And it's just a question. That's why China just took their extreme stand. You're going to block all encryption because they want to see everything, because that's the way they are over there. They have no concern with civil rights. They just want to see everything and control everything and make sure everybody's doing what they're told. That's the sort of Orwellian nightmare they have over there. They're way over on one side of the scale. The United States is typically more towards the other side, more freedom and chaos and less government control, but we oscillate. Anyway. So here's some formats. AFF is what Access Data's native format is. Expert Witness is an old tool, not used much anymore, but they defined the first format to make a nice condensed image of a drive. They just break it into chunks about 2 gigabytes of zip data, so you can put it on floppies and USB sticks, formatted fat and all that jazz. So it's easy to store and compress. So that's the standard. Everybody mostly uses in Expert Witness format. That's in Case's default format, and all commercial tools can read that because that's the standard format people store images in. All right, they're both compressed formats and split data into many files so that it can easily be copied onto FAT32 formatted volumes, like thumb drives. DD files are the simplest copy, where you just have one file that's exactly as big as the original whole hard drive. And therefore, the only place you could store it is on a bigger hard drive. And it's a drag to put it over networks or anything. So, this is the simplest one in principle, but in practice, pretty hard to handle. All right. So you got to have documentation. The DD format, by the way, does not include any hashes or anything. The other formats do, because this is just a literal copy of the disk. It doesn't have any place to put extra data. The other one has a metadata section with the name of the investigator, the date it was collected, the SHA-1 hash, the start and stop time. They have, since it's their proprietary format, they just added a page of extra information to store with it that you would want. But DD doesn't have any space for that. You can put a text file next to it on the drive saying storing that, and you should, but the format itself has no place to put any more data. So let's again, all of them are mathematically identical. The E01 and the AFF format are exactly equal to the DD file, except it's just compressed. So if you uncompress it, you get exactly the same thing. So they have the same data in every way. That's the point. You can convert one to another with free tools. It's fine. Open source tools typically like the DD file. Commercial tools pretty much all want the NCase format. If you have baffling things like multi-disk arrays, like RAID arrays, then most people would say DD files are better because of the RAID array. If you have 3 disks, then the data, if you have disk 1, disk 2, and disk 3, the data is actually 64 kilobytes on disk 1, then 64 kilobytes on disk 2, then 64 kilobytes on disk 3. And so you'd have to slice the data up like salami and reassemble it to get the files. So you'd probably want just simple, straight copies of all those disks to write a script or something to reconstruct the data from in all that junk. All right, so I got some Cahoots. This is 8A, which is right here. And I'll start this. I'll go find my text file. (152) hooch 10, 10, 19. All right, there we go. All right. I've only got a few people online. Now, chat message, okay. Is it possible to get live images, including RAM? Yes, you totally can. You can view it right in DD, and you can use Memorize to get it. There are various tools that you do it, and we did it in one of the projects. We did an image of just one process, but you can do the image of all the processes. Let me bring it up. Well, I'm going to open another window over here. While people are joining the Cahoots, I can point you to it. I think we did it in this 152 class, in like project 3. See if I can get it on this part of the screen. Yeah. Yeah, capturing RAM from a process. There you are. You can capture the RAM from the browser, for example, this way, and you can do it with actually proc dump, which is a Windows tool from sysinternals. That'll dump the RAM from a process, and you can get other tools that will just dump all the RAM. I think FTK Imager could do it. You can just dump all the data from the RAM and make a file. So if you have 4 gigs of RAM, you'll just get a 4 gigabyte file with every byte in RAM. And then you can hunt through that and find strings and such. It's not enormously useful because there's no timestamps, no owners in RAM, but you'll find clues there for like running malware and such. Good. And maybe we got enough people. My goodness, it might be an imposter. Anyway, this is probably Ed. All right, so I guess we can go. Let's give it a shot. All right, a hidden part of a hard disk. Okay, that's the host protected area. That's correct. I see a chat message. Let me see what that is. Can you image a disk remotely? Yes, you can image it with DD and connect it to a network port with like FTP or any other network protocol. I'm not sure about rsync, but you can connect it with, in principle, you can chain it, you can send it over the network just like any other file. It's just kind of a big data transfer, but you could send it over any network connection. And there are some simple Linux commands that will take a DD to make a copy and then pipe it to through netcat and send it over the wire. You can even pipe it through GZ to zip it and then send a zip thing over the wire and pick it up the other end. You can totally do it that way. All right, anyway, so let's try the next one of these. So which one will let you recover deleted files? Okay, and that's the point. If you have a forensic image, you have every bit on the hard drive, and therefore you can find some deleted files. All right, you might find some stuff in RAM that was part of a deleted file, but you wouldn't find the entire file intact, not normally. So what kind of acquisition has the best chance of recovering deleted files? Disk is the best. Partition is not bad. However, if there are multiple partitions, you won't get the files in the other partition. And if someone actually repartitioned the disk, trying to get rid of the files, which you could do, then you would want the whole disk image to get that. Anyway, all right. So what kind of acquisition can ensure that you get only files owned by the suspect? Which is typically what you have to do on a shared device because your court order typically only covers one suspect. This is what we all wish the NSA was doing, and they're totally not doing, is getting just the data from the people they have probable cause for. So that's a logical image. Those have to be live files with an owner, and now you can get just the files attached to that one owner. All right, so what kind of image is most likely to be accepted as evidence in court? Yeah, that's the point. Encase advertises that their tool is accepted in court better, and that is just garbage. You can use anything. It is up to the forensic examiner to explain what they did. You can write your own tool in Python or something, and then you just have to defend it in court. And if you're impressive enough, they take it. It is, the evidence is the human. The technical means are not important. The human has to convince people what they did made sense. And so that's, you can do anything you want as long as you can defend it. However, Encase's marketing point is if you just use the standard Encase tool, then you don't have to like defend it in court and be an expert. You can just say, I use the standard tool everybody else uses, so that should end all argument about the quality of the tool. And that is probably true. Anyway, so what kind of image is easiest to use with open source tools? Okay, and that's the raw image, DD. All right, so Caitlin is here. M. Hino, these are real names today. Good. Whoops, I get, okay. And Ignacio, good. Okay, so let's go back to here and, all right, so there's good old-fashioned traditional duplication. This is the original kind, a static image. You have a hard drive, you turn off the computer, typically by just kicking the plug out, so you don't go through a shutdown process. But anyway, you have just a hard drive with the power off. Now, you connect a power to the hard drive, you connect a write blocker to the hard drive, and now you copy it that way. And this way you get a perfect image with no alteration of the hard drive at all, as long as the hard drive doesn't have any errors. You can also have a software write blocker, like booting from a forensic disk, which mounts the disk in a way that it doesn't write anything. Now, in the early days, like 15 years ago, hard drives used these IDE cables that are about 18 wires, and you could just take wire cutters and cut the right wire. And then it could only be used to read and not write, and that's all you had to do to make a write blocker, was just cut one wire in the cable. But modern hard drives are much more complicated, and modern operating systems are much more complicated. I learned this the hard way. When I was teaching Windows XP desktop support in a lab using a shared computer, and so another teacher was teaching Windows 2003 Server in there. And I upgraded my Windows XP to Vista, and Server stopped booting. And I said, how can this be? My OS was on like drive C and their OS was on drive D. So how does changing drive C change drive D? And the fact is, when you boot up the machine, it changes the contents of every drive. This is true of Windows and Linux. When it boots up, it's going to let you see this window. If I'm going to install my Windows machine here. Yeah, if you go here and go into My Computer and go to Computer here, it shows you the drive, C. And if there's a D and E, just showing me that, it writes on the drive to create that. And the reason it does is because of disk errors. You may remember Windows 98. If you were running Windows 98 and you get the blue screen of death, when you restart the computer, it will freeze for like 20 minutes. And you'll see this thing crawling across the screen saying, hunting for lost sectors. The problem is, if the computer was doing something like copying a file to another location, and it copied block 1, it copied block 2, and then blue screen of death, it finds these blocks of data and it doesn't know what they are. It didn't keep any records of what it was doing, so it finds this data, which is apparently in use, but it doesn't know what it means. So it has people up and put it in the root of the drive called file 000, file 001, file 002, because it doesn't know what to do with it, finding lost clusters. To prevent that, NTFS added journaling, and all Linux formats have had it. So it actually keeps track of what it's doing. It's got a journal on the drive that says, I'm copying a file from here to there. I'm copying block 1. I'm copying block 2. I'm copying block 3. Blue screen of death. Now when I restart, I look at the journal, I don't wonder what, I know what this stuff is. I can now pick up where I left off and finish the job. That's what it does. So when you boot up, it records that in the journal. It changes the contents of the drive, and it will create a trash can. And the problem that I encountered was Vista would upgrade the journal version to a version that was not accepted by the Windows 2003 bootloader. So if you have a multi-boot machine and you upgrade XP to Vista, 2003 won't boot anymore. And I felt very abused. But that's the way it is. And I learned a lesson. A modern hard drive changes the contents of every partition during boot up. Even if you're not writing anything, it writes some things. Yeah.
So that what you just said,
Yeah.
even if you have a separate drive, let's say you have 2 SSDs
Yes.
on your desktop,
Yes, if
One
it,
is drive C, one is drive B, it's the same thing, right?
if you pull the power plug out of one, it won't change. But if the power is in and if it shows up here, just it being visible here involves writing to the drive. And the amount of data can be pretty large, actually. So a modern write blocker that makes it possible has to actually have a bunch of hardware in it, and it can cost like 400 bucks. A modern write blocker in the middle is this box, and it's got a processor and memory, and the computer thinks it's updating the journal and creating the trash can and changing timestamps on the drive, and this thing lies to the computer to tell it all that is happening and doesn't really put it on the disk. It's actually a big sophisticated box now to make a write blocker. That's what they, yeah.
Why can't you just make a version of Linux for forensics and just plug in a hard drive and it doesn't do anything when you plug it in?
You can. There are versions of Linux. There's several forensic distributions that do that. They turn off all this junk so they really don't write on the drive. And that's why you can either have hardware, which should be much more reliable, or you can have special Linux versions that do it in software. And by the way, you can also change sort of undocumented registry keys in Windows that stop it from writing on certain kinds of drives like USBs. But that's not really supported, and you don't really know if it worked. But technically, you can have software write blockers in both Windows and Linux. Just in practice, real forensic examiners I've talked to say just pay for a write blocker, because the fact is you'll hit the wrong button in that stinking software sooner or later and wipe out the drive, and you'll be sorry. If you just use a hardware thing, you can't get it wrong. That's what they say. Anyway, so that industry leaders, Tableau and Wybatech are big ones. You pay hundreds of dollars, and you have to buy more write blockers for all the different types of plugs that come in as your hard drives. And as for cell phones, you can pay $10,000 for a cell phone imaging kit that comes with hundreds of adapters for all the different cell phones. There's an unbelievable number of cell phones. They all have different cables, and they make write blockers and imagers for all of them. But you pay a pile of money for it. Yeah.
Why don't hard drive manufacturers make a standard for forensics? Like just an extra port that you can.
I don't think.
Like a serial port.
I don't think anybody cares. Now that's what they might like in maybe Russia, where they're going to demand to investigate everything. But over here, computer operating system makers and hardware makers couldn't care less about forensics. They have no interest in actually tracking what you're doing for the police. Maybe Red Star would do that. But I mean, their only concern is to make it faster for normal users. Normal users don't want to pay more money to make it more convenient for the police to investigate my machine. That's kind of screwy. That's all. I mean, now I can see how maybe a company might want to buy a special recording hard drive, but they don't build hardware for that. They build software for that. Like your mobile device management system and your domain controllers, they really are monitoring what you're doing, your intrusion detection system, and your user behavior analytics system. At companies, they do have software that is in fact spying on everything you do and reporting to management, but they don't build it into hardware yet, although there were some news articles about hardware they would put in your desk that will take a picture of you to see if you're sitting down and working or if you're up playing around in the lunchroom, and things you'll wear with Bluetooth on them that record everywhere you go and what you're doing. So it is getting there. But, you know, and the Chinese thing that will record pictures of you everywhere and track you, I mean, you can do that. But as far as I know, nobody's made hard drives specifically easy to image. You could. Anyway, and so, yeah.
I could see Samsung being the first company to do that. I could be wrong.
Yeah, I know that Panasonic makes the Tough Book, which is real popular for another reason. That's the one that's just physically hard. You can drive over with a truck and dump it in a puddle and leave it in a fire and it won't break. That's one thing. But one that, you know, keeps an extra record of everything you do, there could be a reason for that, for like NSA or something. I don't know. Anyway, so right now you do all that in software. So Deft is one of the many forensic distributions. I like Deft. I used to use it when I taught forensics because it could image the Mac. But anyway, this has a special version of booting up that doesn't change anything. So you don't need a write blocker if you use this correctly. All right, so you can use any tool to do the image creation. DD is the standard Linux tool that just duplicates. It takes what's here and puts it there. There are versions like DC3DD, came from a digital forensic lab in Florida, a government lab, and it just does a DD, but then it does like a second pass and verifies it, and it calculates the hash and puts it in a file next to it. It just has a couple extra features to make it more useful for forensic examiners. But most people prefer to use Windows instead of Linux command line tools, so they use FTK Imager or Encase. So they can run it on Windows, and then you have to have a write blocker because your Windows has not got this ability to prevent write blocking. Anyway, there's another thing you can get. One of my students had one of these, a hardware disk duplicator. This is if you're serious about it. You just have source destination. Run it. It's nice and fast. It's automatically does it right. And this is not really intended for forensic work, although you can use it for forensic work. It's intended to deploy images, but they exist. You can buy these things, and that's what the pros do. Professional forensic examiners spend many, many thousands of dollars on all this fancy stuff because they make a lot of money, and anything that makes it faster and more reliable is better. And then you can have like junior members of your team that are just doing copying the disk using some tool that makes it dirt simple, where it's not easy for them to get it backwards. But you just have to have one case where you accidentally copy your blank on top of the evidence, and you'll be sorry, and you'll realize it's worth paying for an idiot-proof tool. Anyway, so here's conditions. Make sure your source media is write protected in some way with a write blocker or something. Make sure your examination environment isn't going to do anything automatically, like have a Java update pop up or any damn thing. Make sure you have enough room to store the files. Make sure you have some way to address the source media, and make sure you know your command line options that you're using. So DSDD is the raw Linux tool that will copy a disk to another disk. These other ones are ones that just add a few missing features like hashes and error correction and such from US defense labs. You can now, let's say modern operating systems automatically mounts the drive and automatically writes on it for things like timestamps and journal, and we don't want that. So your best defense is a hardware write blocker, but a software write blocker, like a special Linux distribution, is a cheap alternative if you want to go there. Encase gives you a bunch of ways to create forensic images. You can run Encase forensic, do it right in Windows. Your command line utilities available. There's a Linux-based boot disk that comes from Encase that will do an acquisition. You have to pay for Encase to use any of these. FTK chose to make their imager tool free, which was nice of them. And then you have live system duplication. Now, this is the much sloppier process, which is better for incident response normally, where you don't shut down the machine and image the hard drive. You run software on the machine to collect information about it while it's going. This is a live image. And this is called a smear because you're reading something that is changing. And if you do it a second time, you don't get the same answer. And so the data you get from the first part of the disk is at one time, and the data you get from the other part of the disk is actually at a later time. So this is like, you know, a blurry photograph where you move the camera while the image is going. You're getting something that did come from the target system, but not at all as clean and beautiful as a static disk image where you get one answer and you could do it again, you'll get exactly the same answer. Not at all. But anyway, this is what you'll often have, for example, for encrypted drives, like he was asking. If you want to image an encrypted drive, what you do is you get the password and log in, and then you make a live image. That's all you can really do. Anyway, so you have in live images, you clearly have no write blocker. You're connecting to a live machine that's running. You are changing the system. You're running some kind of software on the system. So part of the image you're collecting is what you put on there. So that's an issue. And the machine might crash. You might make it run slow. You should try and do as little change as possible. Don't be installing software on that system. Just be running software from somewhere else. Run it from a share or removable media. But it is absolutely the case that your final product does contain some data that you put on there, and you have to understand this is the data I put on to make the image, and here's the data that the PERT put on, which proves that they did something. So Apple hardware is really hard to handle. iPhones and Macs, and especially MacBook Airs, the components are all integrated. It's hard to take apart. Even if you do take it apart, it's hard to get the hard drive out. This is why, you know, people want to upgrade the SSD and a MacBook Air have a problem. They use weird connectors. Now, one option is you can reboot your device in target disk mode, where it runs like just your movable hard drive, and then you can image it through the Thunderbolt port or something. And Tableau sells a FireWire write blocker. You can do this. It can just be expensive, and Deft can do it for a MacBook Air through the Thunderbird port with a software write blocker, or so they say. I haven't really tried it. Anyway, then there's these big disk arrays, RAID, storage attached networks, network attached storage. These things are huge and complicated. Imaging the whole thing is sort of insane. It's hard to imagine why you really need to do that. In principle, you could, but in fact, you would just get a mess of huge files that you have to somehow piece back together. The only people I think that do this are like drive savers. Drive savers, it's funny, I told them, gee, I back up my stuff in the cloud. And they said, boy, if you only knew. All those cloud services you're trusting, they come to us to recover their stuff because those things crash. And so they're bringing in like a 12 disk array with 10 terabytes in each disk to be fixed because it's crashed. And that's what's really happening when you're saving it on who knows what, Dropbox or OneDrive or something. And they actually do this, take all the data off all those drives, piece it all together, repair what they can, and give it back to them. But that is like a heroic, complicated task, not something a normal forensic examiner would do. There are a few specialists in that, and Drive Savers is the industry leader. That's why people love it. If you're at Drive Savers, they really understand how to do this complicated stuff, which most people would just give up and use a simpler technique before doing all that work. And then there's virtual machines, like somebody with, like the first question you asked is very good. My demonstration of that Windows machine, that's a virtual machine. There's not really a hard drive at the sectors in those locations. And this is true of almost everything. Everything is now either a virtual machine or a container pretty much, except these desktop endpoint machines. So if you want to copy a virtual machine, it's actually incredibly easy. If you just look at your virtual machine, if you shut down your virtual machine, you've just got the hard drive here. These VMDK files are just the hard drive. And if your machine is running, that VMem file is the virtual memory, 2 gigs. You can just copy that file, and that's the RAM. And you copy those files, and that's the hard drive. It couldn't be easier. A forensic image of a virtual machine is a snap, if you can get to the host. Although, a forensic image of a Docker container kind of gives me a headache, and I think it's not so much of a snap because Docker runs in overlay FS, which has multiple copies of the same file at a different height, and the effective hard drive is a mixture of modified files and some original files. So I think it would be a whole lot harder to get a simple forensic image of a Docker container. And I haven't heard anybody talk about that because all the textbooks I've read were written before Docker became popular. But now that would be an issue because almost everything is now a Docker container. Anyway.
They go to Drive Savers when they're Docker container drives?
Well, in principle, you go to Drive Savers when your real hardware breaks. That's their thing. They will handle hardware failure. And I guess they reconstruct whatever was on there, including Docker containers. And I'm sure they're probably at the forefront of that. I know if you take them a broken SSD, they will actually do chip-off forensics. If you want to get all the data off an SSD, and it's like broken, or what you do is you have to take all the chips off, unsolder them, put them here, and then read them one by one. And you'll find 1 bit on this chip and 1 bit on that chip and 1 bit on that chip, and have to put those 32 bits together to make a word. And they have got that going. They have a clean room. You walk in there, you wear these bunny suits with the special booties, and they have this floor sucking all the dust off of you. And in the clean room, they have basically a surgery with all these soldering stations and everything where they're taking apart the chips and putting them on other boards. And they have bookcases full of every hard drive ever made. They have like tons of they have complete hardware of every hard drive. So what they can do is they can take the platters out of your hard drive and put them in another, or take the boards out of your hard drive that failed and replace them with exact boards from another one, the same model. They really have got it going on, and it's expensive. They said it will cost you 10 times as much to recover your data as it would have to buy another drive and back it up. But they can really get your data back. They get it from machines that have been dropped in the bottom of a lake, machines have been in car wrecks, machines have been in fires.
They had a little thing to show us that this hard drive was virtually destroyed, and we got, it's all burned.
Yeah. And if you go to their tours sometimes, which is great, they've got like stills from Hollywood movies, like Toy Story, all the major movies, they saved them. Like they lost, after they put like a year of work into Toy Story, the Toy Story 2, the disc crashed and they lost the whole movie. And Drive Savers got it back because, that was all computer graphics. And so it's like, 100,000 hours of computer time to make these processing. And it's so expensive, they can't have a backup or another copy or anything. And then the disk crashes. And Drive Saver recovered it. So they gave them like the Toy Story model they can put in a case. They've recovered everybody's data. Yeah. And people there are very happy. They stay there for like 20 years. They treat them well, which is not common in this business. Most people have jump ship every 2 years because they don't get treated well. Yeah, they're in Nevada. And the people there are very happy. And everybody gets like 6 weeks of training every year where they fly you to wherever you want to go and they give you the latest training in the latest techniques for the latest stuff. So they're like the experts. And when I went there like 4 years ago for a tour, they had just opened their criminal division. So now they will do court type forensics, and they will then send expert witnesses to court to testify exactly how they got that data and what it means, because that's the related field they got into. They originally were mostly just to recover lost data for people who want their data back. But the court thing was another part, and now they have like a legal division that will make sure they fill out the right forms and everything, which is great. So your police department could just pay them to do all that, which is probably a lot better than trying to run your own lab for small police departments.
So they can check all your phone calls that you ever made?
Well, yes. Although I don't know if they can get on every iPhone. I know Celebrite can get in every iPhone and every Android phone. I don't know if drive savers can do that, but I wouldn't be surprised. Anyway, so let's see. If I want to have the easiest setup for recovering data use VMs, well, I don't know if that's really true. I mean, you can make a backup of anything. If you use cloud machines or cloud backups, you do have to have some backup solution. I think it depends on what you're doing. If you have a really large amount of data in your own server farm, then you probably can't move it over your network. So you probably want to have like a physical USB hard drive you put it on. If you're in the cloud, then your cloud provider probably has a backup option. There are many different forms of backups to make. You have to have some kind of backups though, and some kind of non-live backups in these days of ransomware. That's what I'm afraid of. If I get ransomware, it'll log into all my accounts and delete all my backups in the cloud too, and that would be very annoying. So it would be nice to have some backup that is not accessible through an automatic login from my browser. Anyway, these are very good questions. I think we're down to the last cahoots, so let's take a look at them. And I'll see if I can get this stuff off my screen. Okay. So 8B is here. All right. I think I see Caitlin drawing some complicated thing. Or did you settle for a butterfly, perhaps?
Very,
What's that?
very.
That's he's the butterfly. Okay. I saw her go on. I thought you were spelling out something complicated. Might just be texting somebody. Anyway. All right. I'll wait a few seconds to see if we got any more, but I think we only had 9 last time, so 9 might be the number. Apparently so. Okay. So, software included in every Linux system. Okay, that's DD, just to copy data. All right, free Windows software. FTK Imager, that's right. What's that? Well, that's possible. I hope not. We'll see. A valid forensic image just by copying a few files. Yes, well, I was having the same feeling. But of course you don't know. All right, so that's virtual machines. You can just copy the file. And you notice it's not having much effect on the results. Okay, particularly helpful on Macs. Oh, well, I guess, so there, ha, ha, I say at you, ha.
Oh.
Target disk is that mode, Mac mode makes it easy to copy things, and ha, it just happened to be AAA. It wasn't like it was always A. All right, so there we go. Butterfly is who? That's you, okay, good. Okay, Butterfly is Caitlin. And Joe Chong looks like a real name. And AC Slater, that might be a real name, is it? I'm going to assume it is unless I hear otherwise. Aha, a chat message is coming in. MH. Oh, okay. So that's, okay, AC Slater. Okay, so I'll just put it up here. Good. Okay, thank you. All right, good. So I got the names of people, and okay. And I think that's it. I'll stick around if people want help on projects. I'm getting a lot more customers for that lately. If anybody online has any questions, let me know. But absent that, I'm going to stop the share and just help people that are in the classroom if they want help. Okay, I'll see you folks next week. This is Thursday. We will have a class next week. Next Tuesday is a holiday for some silly reason, but not next Thursday.
It says Tuesday next week, right?
Yeah, Tuesday next week, there's no class. But Monday there is class, even though Monday is a federal holiday. It's a little more senseless than usual around here, but that's the way it is.